Okay, so I think maybe we will start today. Now, people who join later can view the stream anyway, even from the beginning. So let's start a little bit about my background. I come from Czech Republic. I was born and raised in Czech Republic, and I also studied university here in Czech Technical University in Prague, and I studied software engineering both times. During the studies, I also went to Korea 3 times as an exchange student, and before joining Home Credit, I worked for a company called Eki in Prague until the last year, and since last year I am working for Home Credit, and recently, a month ago, I became the tech lead of the Android development in Home Credit. I don't do only Android development. I like technologies in general, and I like to experiment with various other frameworks and technologies. For example, many years ago, I did some basic game development. Also, I made a few years ago a primitive programming language that was actually in one sense better than Java because it allowed to have nested functions, which is now available in Kotlin. But like as the only person working on it, it didn't have any future. And another thing, for example, earlier this year, I wrote a quantum computer simulator that simulates the qubits and quantum entanglement and all this other quantum related stuff. So first, I would like to talk about software architecture before we get to anything Android related. And I think it's important to take this step back and talk about architecture in general and have a look how it evolved over time and understand the basics first before we actually apply it to Android. And also try to understand why is it a good idea in general to have an architecture when developing pretty much any software. And I would like to introduce you to this, specifically how I learned about various software architectures. So in high school times, last year of high school, I created a small game. It was written completely in Flash, and I was pretty proud of it. And it had local multiplayer that multiple people could play on the local network. And it was an arena kind of game where people either try to eliminate each other or capture other team's flags. And each player had several abilities at their disposal to navigate in the game and reach the goal. At the time, I thought the correct approach to writing the games would be the object-oriented approach, and because object-oriented programming is generally good. But as I was writing this application, over the time the complexity of the whole project was increasing, and when I reached the point where I wanted to add new characters with different set of abilities, it was maybe not just difficult, it was nearly impossible because everything was just crammed together and everything was tangled together. Everything knew about other things. So for example, when I had the player class, it knew where is the location, it knew how to use some abilities, it knew about its health, and it was responsible for so many things, and everything was already expecting other things to behave that way. So you could call it spaghetti code, and I would rightfully agree with that statement. And the problem with this is that the object-oriented approach is not always the best solution for everything. And in games, typically, there are quite complex interactions between different components. So if you try to create this kind of inheritance hierarchy, where you have an object that is renderable on the screen, and For example, you want to implement an enemy, and you create this inheritance where it should be renderable on the screen, it should collide with the walls, and it is controlled by artificial intelligence. You could create maybe a hierarchy like this. But like now, if you try to add a new type of enemy, for example, a ghost, you suddenly have a problem. Like the ghost should not be, maybe it should be renderable, maybe not, that's I don't know, but it definitely should not be collidable. It could walk through the walls, and suddenly you are in this situation where you cannot really like extend it from the enemy because it is not collidable. So you try to create a new branch of hierarchy where the collidable class is not in the hierarchy, or maybe you try to reorganize the objects and what inherits from what. But anyway, you will always like more and more reach these problems where you cannot fit a new component into the system. And that's why in the games they use something called entity component system architecture that actually tries to move away from the object-oriented programming, and everything in the game is an entity. So a player is entity, ghost, enemy is entity, the tree is entity, water particles are entity as well. And each of these entities have a set of components. For example, for the player it will be position, velocity, it can collide, it can be controlled, rendered, etc. But other entities like the ghost, it can only define some of these components and not all of them. So for example, it should not define the controllable component when it is not controlled by the player. And then you have the systems that iterate over all the entities in the game and only check the entities that have specific components attached to them. And for example, when we have the render system, it will just check all the entities that have a position and they can be rendered on the screen. And it takes all of these and displays them on the screen. Okay. I wanted to showcase this architecture because it's commonly not really known between like normal people. A lot of people know just about MVC and maybe its derivatives, but I think this displays all the features or like the benefits of architecture. So if you try to implement something without an architecture in mind, at the beginning you can like create a lot of code and you feel like you are adding a lot of functionality, but over the time the structure is getting increasingly more complicated, and the curve is like getting into like almost horizontal line, where even to just a little bit more of functionality, it takes incredible time to add a new feature, and it gets progressively harder and harder. On the other hand, if you choose the architecture correctly and follow the architecture and try to keep the code clean by refactoring the code if you find something not well thought out, you can get this another curve where at the beginning it seems like you are wasting time because in the same amount of time you could get much more functionality. But actually the curve is like raising up. It's not slowing down. It's increasingly faster and faster. That in the end, when you want to add a new functionality to the software, it might be actually easier and progressively get easier. So for example, now if I had the game that would be designed in the correct way, adding the ghost enemy would be like really simple. I would just define an entity that has the position and not collidable, but what was the last one? I don't know. It would be just much easier because everything else is already prepared for it, and the render system would just check yes, it is valid, and the collide system would say like no, I'm not checking this entity. So correct approach can correct architecture can change a lot of things. Yes, choosing the right architecture can have a huge impact on the future development. And if you ask the question like what actually is a software architecture, I think the right answer is just it depends, because it really just depends on who you ask. Like if you ask a game developer, it will be different from someone who develops an Android applications or someone who develops it on the backend. And also it is like personal kind of feeling, like some people are more shifted this way and some people more shifted that way. And it also depends like when you ask this question. If you ask the question nowadays, you will probably get a different answer than if you ask people 20 years ago or 40 years ago. So ultimately it becomes kind of like a philosophical question where none of the answers are right and none of them are wrong, and it's more about the personal understanding of what software architecture means to you. One thing that should be noted is that choosing right architecture is a really important step, something that you should decide on early in the development of the project, because it is quite difficult to change the architecture later down the line. So I already talked about this entity component system architecture that is dominant in the game development. But if you look at the backend world, they use microservices where each service is responsible just for one small specific responsibility. So for example, login service is only tied to the login logic and it does not know anything more. It just provides maybe authentication keys and that's it. And these services then communicate with each other, and this is the topmost structure of backend servers. On the other hand, for front-end user-facing applications like Android, we typically use something called model view something. The most typically known example of model view something is MVC, model view controller, and I would like to talk about MVC right now. You can think about MVC as the great grandfather of many other architectures. Today it would be actually 40 years old because it was first introduced in Smalltalk in 1980. And if you try to understand the MVC today, it is very different from the time when it was first published in Smalltalk. And you can maybe look at it the same way as the Smalltalk was like the first like really object-oriented language where everything was an object, and it differs a little bit from the definition of OOP we have today. So for example, we regard Java and C++ or C#, Objective-C as object-oriented languages, but back then it meant a little bit something more, because even like the functions themselves were objects and like there were messages. It was different mindset about object-oriented programming. One of the things over the time, the MVC was adopted by different platforms and frameworks that they tried to take the original MVC and apply it to their own platform, but it could not always be done like without bending it a little bit. And that's why like nowadays if you try to search for MVC online, you will find so many different definitions of what MVC is. If you search for MVC in Smalltalk, it will be different from MVC in PHP. It will be different from MVC in JavaFX. It will be different from Android. So let's have a look how it was actually implemented originally. So this is one of the first, or maybe the very first diagram how the model, view, and controller interacted with each other. When the user made any action in the application, he was directly notifying the controller. This controller then took the action and did some logic, and it updated and manipulated the model. And in the original design, the model was actually observed by the view. So the view, whenever the model was changed, the view automatically got the updated data, and it displayed this data to the user. The main idea of this whole thing was to separate the model from the view and the controller, so that you could take a model and test it separately without any dependencies. And this was progressively with other architectures even more improved, and we will get to that. There is actually one more way how the MVC was implemented in some other frameworks. That there was no observer pattern, but instead the controller manipulated the model, and afterwards it directly let the view know that something has changed, and the view retrieved the data by itself. And then it updated its view and showed the result to the user. The difference, they are called observer synchronization or flow synchronization, depending if it is observing or not. So we've discussed MVC in general. There are many derivatives of MVC pattern. As an Android developers, you probably heard about MVP and MVVM. But if you, for example, look at the web development, they came up with something called presentation abstraction control and hierarchical model view controller. These two architectures are pretty similar. And they just take the basic MVC and try to make it more hierarchical, so there is not one huge MVC, but hierarchical. It makes sense, right? And if you look, for example, to our competitor Apple on iOS, they use MVC actually by default. It's in their code by default that they have view and view controller. But still people were not quite satisfied with MVC in that form and came up with other derivatives like Viper or View Interactor Presenter. Talking about MVC, one of the main principles of MVC was to divide all the code into presentation and domain level. I think this is the most important part of MVC and pretty much all of its derivatives, and it is valid in all of its derivatives, even if you use MVP or MVVM. So in this kind of implementation, the view does not care or even does not know about the business logic. Only thing it cares about is how to display its data to the user. And on the other hand, the business logic does not really care how it is displayed to the user, and just cares about the core logic of its business. One thing, this also enables us or the program to be implemented once, but be provided or shown to the user in multiple ways. So you can think about some tools that have a graphical interface. That is one way to display to present the application to the user, or the other one can be just command line interface. And both of them are actually using the same business logic. The only thing that is different is the presentation logic in the view. Okay, so now I would like to finally get to the Android specific things and how we can apply different architectures in Android. Android has some peculiarities. One of the main peculiarities is that memory in general on mobile devices is generally scarce. and that there is a constrained memory. And so that's why Google, when they were preparing the Android, they came up with this idea of life cycles. That, for example, you have an application that the user is using, and then he switches the applications, he's using another one, and then at this point it's not really necessary to hold the whole view hierarchy in the memory because it's not visible to the user, and technically it can be just reclaimed by the system and use the memory for some other purposes. Another thing that plays a big role in the Android framework is configuration changes. That's something that everyone hates, but it is actually a clever idea. Typically, configuration changes happen when the user rotates the screen, or when the user enters the split screen. Then I think it's called split screen, where you have two applications running next to each other. Or also on Samsung phones, they have something called floating window that allows you to just drag and resize windows as if it was like normal desktop. And all these things were just resizing of the application, but the configuration change happened also in other cases. For example, when the user changes his language in the system, that will trigger a configuration change. Also when he changes the font size for either visibility, like accessibility reasons or whatever. All of these things that I just mentioned, they can be like explicitly blocked in the Android manifest, that when this thing happens, the system, the framework should just ignore it and let the activity continue its life. But even though you can do this and like save yourself a little bit of trouble, you still should handle the configuration changes manually, because if your application goes to the background, then the Android framework can at any moment destroy your view, and at this moment you definitely should save the state so it can be later restored. So by disabling the rotation or anything in the Android manifest, you are not going to avoid the configuration changes completely, and it's part of the system. You should not fight it, you should just abide the rules. Let's talk about the Android architecture. Android actually does not enforce any architecture by default. And if you go back maybe 10 years ago, at the time I was not using writing Android applications yet, but at the time people were using MVC if they try to use some architecture. But they realized some problems how MVC is implemented on Android, and that it's not as easy to test. And this is why over the time people came up with the idea of MVP. I don't think it originated in Android, but people applied it to MVP, and it is actually, I think, used even nowadays in some applications. But recently, I think 2018 or something, Google came up with its Jetpack libraries. And one of these libraries is actually about view model that we are using nowadays in many of our applications. I would like to also point out that there is another architecture called MVI, Model View Intent, that is being used by some companies, but I would consider this architecture a little bit advanced because it requires you to understand the reactive programming, and that's not something everyone is comfortable with, and that's why I will also not cover it in this talk. So if we look at the MVC in the Android, there are actually two ways how to implement it. The first and very naive way is that the view, the activity or the fragment itself is the controller, and the XML layout is the only view. This had a problem that like everything that you put into the controller and the logic there is difficult to test because it is part of the Android framework, and as we will talk about later in the testing part, it's difficult to achieve. And the other approach is to actually create a separate class for the controller that the activities and fragments are views in addition to the XML layout. These are probably not, I hope they are not used in any applications anymore, and I will just continue with the MVP, which is still today used in today world. So in MVP, there is a little bit shift how the for the model, view, and presenter in this case communicating with each other. There is no longer this connection between the view and model directly, but everything always goes through the presenter. There is one-to-one mapping between view and presenter, and there is one-to-one mapping between view and the presenter, and actually both of them implement an interface that they are the other side. The view is interacting with the interface of the presenter and vice versa. And in this architecture, the view should be as simple as possible. In the best scenario, it should be completely declarative. So for example, if you look at the XML code, that's purely declarative language, and you cannot really put there like any if statements or conditions. So that's a good thing. And view should stay as simple as possible to facilitate the testing. From my perspective, whenever I was using MVP, it often resulted in a situation that, like, even though it is separated into the view and the presenter, because how they communicated together, it all felt still like really tightly coupled one component, and it felt like ping pong. Like you invoke some action, like for example click on a button in the view and it sends the event to the presenter does some logic, gets maybe some data from the model, then updates the view, but because the view was updated, it will trigger another event on the presenter that triggers another update of the view, and it was just jumping here and there, and it was not really clearly separated. And although you could test the presenter in much better than you could test the controller in MVC, it was still a bit problematic, at least in my opinion. Also, one problem that is inherent to Android framework itself is that the view can be destroyed at pretty much any moment. And so, for example, you click a button, the presenter will fire some network request, and it is waiting for the data. It takes for several seconds, and during this period, you rotate the screen. And at that moment, the view is destroyed. Together with the view also goes the presenter, and suddenly you are wasting the resources because you fired a network request that you never actually received a response from, And so when you show the screen again, you have to call it again, and it creates like extra code to get around this, like create maybe some headless fragments or like global something to hold these requests in memory. Let's move to the MVVM. It's actually quite similar to MVP. The communication between view model and model layers are the same. You can keep the logic the same, but the main difference is between the logic, how the view and the view model communicates with each other. In the MVP, we had one-to-one mapping, but in MVVM, we can have one view model, and the view model does not know about the view. So the mapping is like n to 1. And we can have view model without any view connected. We can have one view with one view model. We can have 3 views with one view model. And that's all because the view model no longer knows about what view is connected to it. And to solve this issue, or like how we should send the information back from the view model to the view, is using the observable pattern. This is one huge benefit that actually the view model library is using. The view, as we said, can be destroyed at any moment, and the way how Google implemented a model view model, the view model library, it is stored in some global cache, some hash map that is accessed by some keys, names of the fragments or view models. But view models are no longer destroyed when there is a configuration change, and this allows us to get around the issue where you start a network request and then trigger the configuration change, and then view is destroyed. But in this case, because the view model still lives in the memory, it can then receive the response and update the view, and because it does not care like who is currently connected, if it is no one or multiple of views, it will just publish like, okay, view, you should be showing this data. And when the view later is recreated, it connects to the view model, takes the latest data available from the view model, and displays it. So this is the way how the view model works, and it saves us a lot of issues. Okay, next, if you look at the page on the Android developers website, you can find article or like a guideline called Guide to App Architecture, that is defining the common principles about how to implement a modern Android application. And now I'm quoting the website. The most important principle to follow is separation of concerns. It's a common mistake to write all your code in an activity or a fragment. These UR-based classes should only contain logic that handles UI and operating system interactions. So that's what we are already doing with our MVVM. Activity and fragments are part of a view, and as we said, they should be as simple as possible, so there is no logic. And we are now clearly separating the responsibilities of the view and the presenter or the view model and the model. They also published this picture where there is something called a repository sitting between the view and model, or what is the other? I cannot see it. Remote data source, which you can think of as the model. And in this approach, there is each layer always depends only on the layer below it, and only on the one layer directly below it, no further. So in our case, in this case, the activity only depends on view model, but it does not care anymore about the repositories, or if it is the data is coming from the database or from the network. And repository in this case, it abstracts the data sources from the rest of the app. So for example, when the view model asks for some data to the repository will check like, am I connected to the internet? If yes, it will fetch the data from the server. If no, it can just go and take some cached data from the database. It can do even more complicated stuff, like always return the data from the database first, and in case the user is connected, it will try to fetch the data from the network, or maybe display some message that he's not connected. So I updated my original diagram that it also involves the repository, and you can see that actually the communication between each component is the communication is always the same, that the view is directly communicating to the view model, but view model does not know who's communicating with itself. So it's just publishing its updates through some observable pattern, and we can apply this on every single layer. One thing I also would like to say is that there is not always like one view with one view model with one repository with one database, but it can be intertwined, like maybe in this example. So for example, one view model can have two views depending, for example, if you have a login screen, maybe it can be like full-blown like activity login screen, or it can be also just part of other flow where it is displayed just a dialog fragment, or maybe it displays a little bit different text. The logic behind it stays the same, but the presentation is different. Similar thing can be done on the repository level, that one view model can communicate with multiple repositories. For example, if you have a profile screen, you want to retrieve the information about the currently logged in user from user repository, but you maybe also want to show some other data, like the articles that the user saved to read later, and this data is actually coming from the article repository. So it's not wrong to use multiple repositories for one view model. It is not wrong to have multiple views for one view model. And the repository can also access both the database and network, even though it is not visible in the graph, the diagram. I've been referring to the observer pattern a lot, so let's see how we can actually implement it. This is a little bit controversial topic, at least for me. Historically, we have been using live data, RxJava, that is infamous for how difficult it is to learn it and understand it, because it has so many operators, and even after several years of using RxJava, you can still find new operators that you haven't heard about before. And that's why people rightfully dislike RxJava, and because it was so popular, the Google came up with its own kind of implementation of observable pattern called live data, where the main selling point of the live data was that it was lifecycle aware. So in case you started observing some changes in the view, and the view was actually at that moment where you received the update destroyed or disconnected, it would not push this update to the view because it would crash the application. Meanwhile, with RxJava, you had to take extra measures to handle the disposables by yourself, and it was sometimes tricky to get it right, and it was common to make a mistake. Unfortunately, I would say that this problem with RxJava is the problem of RxJava, the logic behind it. The RxJava is not difficult because it's huge. It's huge because the domain itself is huge, and there are many edge cases that you have to take care of, and make sure that if you do like combination of two streams, they are all lining up as you expect, like through zip or combine latest or something. And this is not by default implemented in live data. In the live data, the only operators you have is map and switch map. I think there are no others. And even though technically you can implement any other operators, like for example, combine latest that I use quite often through the use of mediated live data, it's something that you have to write yourself, and maybe it's like 30 lines of code, and you have to test it yourself, and even if you test it, you are not sure if it will not break in some very specific edge cases. And I think that even nowadays RxJava has its place, because it's already old and tested and does everything that you would try to achieve. So I've discussed now the difference between RxJava and live data. In Kotlin, we have now also coroutines that is a big candidate to actually replace the RxJava completely. And because RxJava, the coroutines also have this flow that is actually really similar to RxJava, that can simulate Distinct until changed. Okay, there is one more transformation in live data, distinct until changed. I didn't know about it. Anyway, you can also use coroutines for this kind of interaction. I have even saw some implementation where the whole application had only coroutines and the flow. There was no mention, no live data and no RxJava, and it was fully reactive. So it's technically possible. Personally, I didn't implement it, and I cannot give much more information about it. From what I would say is the best approach is to use the live data only for the final communication between the view and the view model, because this is the main part that it was the live data was trying to solve, and that is the NoPointer exceptions where the view was disconnected and you try to update it, and the live data takes care of this. But more in the back, like on the repository and model level, you should try to use RxJava or Flow to combine the different streams together. And gradually we got to something called a clean architecture. Clean architecture was coined by Robert Martin, also known as Uncle Bob. And it is not something Android specific, and you may have also came across similar architectures that are called like onion architecture, ports and adapters, hexagonal architecture, or layer architecture. They have pretty much all the same idea. If you look at the diagrams, they might look different, but the core idea is the same, that you have layers that one depend on another, and they are separating the concerns. There are several points to the clean architecture. One is independence of the frameworks. So like you don't have to depend on one specific framework to give you this architecture, but you are using this architecture, it's really flexible. You can update it as you want to create new layers or remove some. And you should use just the framework as a tool and not as something that is limiting your constraints. Second point is that each layer is much easier to test because of small dependencies only on another layer. It is independent of the UI. You can easily just replace the UI layer for different implementation of the view. Similarly, you can just take the database and replace it from Oracle database for MySQL database, and the rest of the application does not even care about this. And the last one is independence of any external agency, which is too technical for me, and I didn't really understand it. So we can again update the MVVM architectural MVVM diagram by adding like 2 more layers. So for example, if you have a view model that over the time increased in size and complexity, and suddenly it has 1000 line of code, and you start to be lost. Like when you try to update the view model, you don't know what else will be modified, or I cannot find the right word, by your changes. So what you can do is just take some of these part of the code and like separate it into a separate class, and maybe this is something called use cases, that actually you should not cram everything into one single view model, but you can like delegate the logic into separate small highly cohesive classes that they instead interact with the repository instead of the view model. And then the view model is just collecting the data from different use cases and does not care about the repository anymore. So if you want, you can add this extra layer. I don't think it's necessary in every situation. Like oftentimes the view models are pretty small, but if you get a big application or big screen with a lot of logic, you can add this extra layer. Similarly, You can add another layer, for example, interactor. Let's say you have a network service where every network request has to be authenticated. So you may create this extra layer that the repository is interacting with instead of the database, instead of the network layer. And this only thing the interactor does is like check if the user is authenticated and retrieve the authentication token that is then sent together with every single request. I would like to also mention FOUCA. I don't know how to pronounce it. FOUCA, I don't know. Operating system. That is a new operating system being developed by Google, and it as well, it learned from the mistakes that the Android did and try to follow the same principles as the clean architecture. And like currently, if you have an update to the Android core system, Android has to like publish this like image that they send to different vendors like Samsung or LG or Huawei, and then they have to implement their own specific changes to that image that is then pushed to the user devices. And this process can take really long time, like maybe I think it takes months or maybe even half a year in some cases, or a year. And that's why like this is really bad point for Google, and they try to fix it. So they define 4 layers. For example, on the lowest level they have Zircon, that is like the kernel and device manager and other low-level system libraries. So whenever they want to fix, for example, a bug in the kernel, they can just update this one layer, push it to the vendors, and because each layer is independent of the other layers, Samsung in many cases will not have to do even any changes and can just push the update in 1 week. So clean architecture is not only for the front end or only for the Android, it can be adopted in many other platforms as well. This kind of mental shift is also happening on iOS, as far as I know, in the Viper or VIP architectures. So also I would like to say a few words about the testing and how you should do tests with MVVM or this clean architecture. In general, there are 2 kinds of testing. One is manual and the other one is automated. I will not talk about the manual because that's something that you should be trying to minimize, and mainly focus on the automated testing. And testing is some extra work that you do now to save you some time and possibly money in the future. Not only because having buggy application is not nice to the users, but because it also takes much more time to create a fix, to test the fix and verify it works correctly and deploy it to the users. And in the meanwhile, the users might have a buggy application that does not allow them to do whatever your application is supposed to do. So the earlier the bug is discovered, the more it has the impact on everyone else. And also you can be just comfortable that whenever you do any changes to the application, you are not breaking something or the existing. In the Android world, we differentiate 2 types of testing, unit tests and instrumentation tests. Unit tests run pretty fast. Each test can run like maybe in 1 millisecond. And the instrumentation tests, on the other hand, are much smaller because maybe they run 1 test per hundreds of milliseconds or maybe even seconds. And this is because loading of the whole Android framework takes a lot of time, and there's just so much more things that has to be prepared in order to test to run. So you should prefer to have much more unit tests in comparison to the instrumentation tests, and maybe this ratio would be like 80% of unit tests and 20% instrumentation tests. How it could apply to our architecture. So let's say we want to test the view model. In the test, we will assume the role of the view. So like we will be interacting with the view model that we are testing. And instead of testing everything that the view model itself depends on, so the repository and the database or whatever, we mock all the dependencies of this view model. So when we create a view model, we provided this fake or mocked dependencies that we specifically define the behavior, how they should act in the test. So this can be also applied to other layers, not only the view model. You can just move it one layer below. That if you are testing the repository, you should mock the database. And if you try to mock the database or the network, let's see, the database, it's a little bit tricky because actually for the databases on Android, it is advised to run it as an instrumentation test and not as a unit test, because the actual database that is running on the device and in the Android framework can have different properties. Like it can run much slower than if you run it as a unit test using in-memory database. But in many cases, if you are just trying to verify if your SQL scripts works correctly, in-memory database is enough, and you can regard this in-memory database as also kind of a mock. So that's it from my side. Let's see what we have talked about. Each language and framework have different features that make some architectures more viable than others, and there is not a single architecture that could be applied in every single framework. The main idea of every architecture is separation of concerns, that the view should only handle the view logic and not the business logic. Because of the testing, it should be also the view should be really simple to reduce the code that has to be tested in views. And over the time, we have seen a gradual shift from no architecture to MVC to MVP that was even better testable, and now we have MVVM and maybe the layered architecture like the clean architecture. And as the last point, I would like to again remind that tests are important to do, and it can save you time and stress in the future. If you want to learn a little bit more about software architectures, I would highly recommend you two people called Robert Martin, also known as the Uncle Bob, as I already mentioned before, or also Martin Fowler. These first two links are from their blogs, and below there are more links for other articles that might be interested in the scope of this presentation. So thank you for listening. I hope you learned something new, and it took 56 minutes to get to this point. I thought it would be a little bit shorter, and maybe now we can have some space for questions. So go to chat. You can ask any questions at all. If I know the answer to the question, I will try to answer. And so let's wait a little bit because there is a delay, I think, of maybe even 30 seconds. Yeah, thank you for joining. No questions or something that you are curious about? It does not have to be specifically about one point in the talk. It can be something that you are just curious that I didn't cover in the talk. Lavi, John, or Nicola is asking, so we can have two or more views and one view model in MVVM. Yes, I would not say you technically can have like two views joined at the same moment to the view model, and it would just work. I don't think there are much use cases where you would do this actually, but technically it's possible. But the situation that I mentioned in my previously was that you have one implementation of the view model that is used at different points of the application. So for example, when you open the application and you try you let the user log in, it will show up one screen with one specific view model, or maybe you can let him in to the application to look around, and when he reached the boundary, like, oh, like if you want to access this, you already have to be registered and logged in. So at the time you can show a different view, for example, like with this extra message like, oh, you reached the end, you have to log in. That would not be normally displayed in the main screen. And you can show it as a dialog, but internally it is using the same view model and the same business logic. I hope that answers the question. Another question is, ArcJava callbacks, live data, and coroutines are alternatives to each other? So definitely there is some overlap between the tools. ArcJava is here for, I think, maybe 5 years, and it has like covered every single edge case covered that you can handle with it. Callbacks, I would not recommend callbacks because they are like too simple. For example, if there is an error, you cannot propagate the error so easily through the callbacks. You would have to create some like composite object that is holding both the data or the error. This is getting close to the functional programming when they have monads and stuff like that. And live data, I would say, is doing a job of ArcJava like from maybe 80%. Like in 80% of the cases where you use ArcJava, you can replace it with live data. But once you want to do something more complicated, like joining two streams or use one stream as a trigger for like starting another stream, these things are very tricky to write using live data. And that's also why I was advocating to use it only between the view and the view model. And the coroutines, currently my use case for coroutines is to use like the only like the suspending functions, and I'm not using the flows yet, because if you think about it, the flow is technically the same thing as ArcJava. They are also re-implementing a lot of existing operators that are in ArcJava, and you can also with some interop libraries convert ArcJava to coroutine flow. So these suspending functions can be a replacement for the single in or completable that you have in ArcJava, but there is like a little bit different approach, and it might be actually even more cleaner way if you use these suspending functions than to use singles and completables in ArcJava. There are more questions popping up. How about data binding in MVVM? Is it recommended to use? Yes, I'm very sorry that I forgot about this point. The data binding is actually, MVVM was first introduced by Microsoft, and they heavily relied on the data binding. And we also got data binding in the Android world that allows you to write like refer to some object maybe in the view model, so you can skip this extra logic that you put into the activity or fragment and directly bind the data in the view model to in the view. And this is also one of the points where the live data actually shines, because they added this support where you can put live data, define live data in the view, and automatically takes the latest value from the view model. So you don't have to write any code in the activity at all, only just like define that the view model is available in the XML layout. And I cannot say I cannot not recommend it. You can definitely use it. It's working, and in my personal experience, I just didn't get to use it much, and personally I don't use it myself. I think not exactly coroutine, but Kotlin flow is more similar, as mentioned by David during the presentation. I think that is the answer to another question. Thank you, Miro. Another question: if you have an existing software that doesn't follow a defined architecture, would you suggest doing it from ground up or migrating slowly to a new architecture? What are your thoughts? Thank you. If you have an existing software, so if I understood it correctly, you inherited the project from someone else. So, for example, someone else was implementing it, and then it just was thrown to you to continue with the project. If they don't have any architecture at all, that can be difficult. But actually, in Home Credit, our application used to be built on top of MVP, and we are migrating slowly away from MVP because some of the classes, as I mentioned during the talk, like grew so much in the size that there is like 1,000 lines of code or 1,500 lines of code in one presenter, and no one actually knows how to refactor it. Where are these like smaller use cases that you can take out and put it into a separate class? And in this case, I would say it's impossible already to slowly refactor it into like smaller chunks. But I would say in most of the other screens, it was possible just to take the screen and convert it to from presenter to view model, more or less. So from the ground up, in general, I don't think it is a great idea to have an application that is working and just like start everything from the ground up just because they have like different architecture. In our project, in our application, we actually have all the MVP, MVVM for now most of the screens, but we also have a feature that is implemented using MVI because someone wanted to try it, and it actually works pretty nicely, and I really like the code. So I would definitely not like just scratch everything. Let's start from ground up, but slowly try to migrate different features to MVVM or the layered architecture. How is it possible to create MVVM for a project not yet well defined? How more difficult it is to transform a project without MVVM in project with MVVM? Let me understand it. How is the best architecture for a POC? POC, do you mean proof of concept? I'm not exactly sure what do you mean by POC. Let me try to read the question again. How is it possible to create MVVM for a project? Well, in some cases, also one of the things I wanted to mention, but I didn't put into the presentation, not always you have to go the full MVVM structure. Like if you have some dialogue that is just showing some like message to the user, like you have been logged out, this fragment does not necessarily have to have a view model. And it definitely does not have to have any references to the repositories and network or whatever. It can be just simple view that lives alone. And these are just recommendations. Like if you feel like something takes a lot of extra work to define like all the different layers, even though your application is really simple, it's not worth it to go as far. You can just do fine with just the view and the view model, and that's it, maybe some model. But even if it is like really simple, you can just go without any architecture and make it dirty and put everything into one activity. It's not recommended because like if you actually try to take the existing code and make it actually like real feature or a real project, you would have to rewrite it from ground up, and that's something up to you to decide, like if you plan to reuse this code later or not. I hope I answered the question at least a little bit and help you. Yes, so POC. What's the architecture for POC? I would like, whenever I do any like POC projects, to show any new functionality just to quickly code down in 1 hour. I do like create a view and view models anyway. I also try, for example, I don't want to create a full database, so I just create a fake in-memory database that is not even database, it's just like hash map in memory. But try to like fit it into the structure of clean architecture. And so in case it's actually going to be reused, it's only the database that have to be improved on. And yeah, so even myself for POCs, I use MVVM. Hoping to have more deeper discussion with unit testing in the future. True, correct. I made it really short, but I wanted to do some also coding, live coding session, but then I realized it would take really long time. So maybe that's something we could do in the future. Actually live coding session where we could look at some examples how to do testing properly. Are you familiar with the network bound resource as provided by Google in their guide to the architecture? Is this something that is being used today, especially in the repository classes? Network bound resource. Let me just quickly Google this up. I don't think I ever heard about that. Oops, can you see me still? Yes. Network bound resource. I don't think I ever heard about this. I cannot answer that question, sorry. You are mentioning the repository. One thing maybe I can add to the repositories is, that the repositories live in the memory, and there is actually no built-in way how to save the state. So in activities, since Android version 1, you had this ability to save the state when it is being destroyed and restore the state when it is recreated. We also recently, maybe last year, got this functionality in view models, that when the view model is being destroyed, it also has this access to some handle where it can store the data. But the repository, it's volatile. It just lives in the memory, and I have often seen like people storing some data in the repository just in the memory. So in the case when the configuration change came, or not configuration change, the application was killed by the system and it was reopened, some of the screens depended on the data being stored in the repository. But because the repository was only updated by some activity that was run before and it was in volatile memory, this data was not available and it caused a crash. That's not something that you would see during the development, but it's evident like from the logs, from the crashlytics we are seeing later. Also, like Google is not providing any like more in-depth logic how the repository should be implemented, but there is a library called it is from New York Times, Store Android. Give me a moment. Yeah, it is called the library is called Store. It is developed by New York Times, and it is something similar to the repository in the Android pattern, in the Android framework, that's trying to achieve the same goal. Our team has been using it a few years ago, but I just really, it's really blurry how it was used. So maybe you can have a look at that as well. Okay, no more questions. Let me read if I didn't miss any. Okay, sorry I was not able to answer the question about network bound resource. I just didn't have a chance to, I never saw it before yet. So I think that's it for today's session. Thank you everyone again for joining us, and hope to see you in the next time. We will be probably sending some questionnaire, like what you would like to see next. And just now another question popped up: do you use Dagger in your application? So this is for me almost like a religious question, like do you use Dagger or do you use something else? And there is Coin that is like well integrated with Kotlin language, and we last year we switched from like handmade injection to Coin, but even now, like half a year or a year later, we are struggling with it because there are some use cases that are difficult. Like for example, you want to go to some activity and start some module only that's available in that activity and scope it to that one activity. And this is really difficult to get right. Even when we tried to get like one fix, then we found a problem with it, another fix, another problem. And nowadays, I just think the best solution would have been to go with Dagger since beginning. And with the recent updates from Google, they officially like say that like you should be using Dagger. It might be because Dagger is actually being developed by Google themselves, but if you look at the latest version of Android Studio 4.0 or 4.01, they are adding a support inside the Android Studio to show like to more easily navigate between different components and modules of the Android of the Dagger. So to answer the question, we don't use the Dagger at this moment, but we are having a really big discussions that we should probably switch from the Coin because it's actually causing the most crashes in our application. If you look to the Crashlytics, the number one reason for crash is that the bean not found crash from Coin, and that's the reason why we are contemplating whether Dagger would be better. And I think in some time we will change to Dagger. Okay, so give it maybe like 30 more seconds. Okay, so thank you everyone for joining one more time, and hope to see you in the next cyber class. Thank you. Bye bye. Have a good day.